What we're going to be looking at for section 1.3 is our order of operations. We're going to be doing a review on the order of operations and how they're used to simplify expressions. Let's review really quick our order of operations. So the P stands for parentheses, and really what the P means is any grouping symbol. The grouping symbol can be a bracket, it can be a set of braces, it can be a large fraction. All it means is you need to do whatever operations are in the top and bottom or the center of the brackets and the braces first. Exponents obviously stands for exponents. Multiplication and division, you need to go in order of left to right. So if you're looking at a problem that has several different multiplications and divisions, always go in order of left to right. Same with addition and subtraction. Go in order of left to right. All right, let's go ahead and look at some of these problems. We're gonna do 4 of these throughout the notes. Let's go ahead and start with a pretty easy one. 5 plus 2 times 3. Now what I actually want to do this twice. I want to do a parallel, and the first time I do it, I'm going to do it incorrectly. And the second time I do it, I'm going to do it correctly. And I want to show you why order of operations, if you didn't know already, why order of operations is so important. So let's go ahead and do this incorrectly first. If I would do this incorrectly, I would do 5 plus 2 first, so 7 times 3, or 21. If I would follow the order of operations correctly, the multiplication would come first, giving me 5 plus 6, or 11. So basically what happened was, a long time ago when we started really developing our math, we decided that we needed to come up with a set of rules. Otherwise, half of society was going to do it incorrectly and come up with the answer 21, and the other half of society would do it correctly, coming up with the answer of 11. So what it did was it created a need for a set of rules for how to simplify long expressions. And that's where the order of operations came from. So it is very important that you do them correctly. If you do them incorrectly, you will come up with the wrong answer most of the time. Let's look at a second and slightly more complicated problem. And from here on out, we're just going to be doing them the correct way. I won't be doing it side by side with an incorrect format. So let's talk about what operations I have. I've got the operation of division, I've got the operation of multiplication, and I've got the operation of addition. It looks like multiplication and division need to come first in this case, and I've got 2 of them. When this happens, as I said earlier, you need to go left to right. So you need to do the 24 divided by 3 first. Well, 24 divided by 3 happens to be 8. Carry down what you didn't underline, times 2 plus 6. Take a minute, we've got a times and a plus. Which one comes first? Obviously the multiplication. 8 times 2 is 16. And then you've got 16 plus 6, which in this case happens to be 22. That would be your correct answer. All right, let's go ahead and look at a third problem, and once again a little bit more complicated. I want you to look at 10 divided by 5 plus 2 times the absolute value of 3 minus 4. In this case, we actually have a grouping symbol. So the grouping symbol would be the absolute value symbol. So that is any time that you're grouping multiple numbers, you've got a grouping symbol. Anytime you're grouping an operation, that's considered a grouping symbol. So I realize I've got division, addition, and subtraction here, but I have to do my grouping symbol first. So I'm going to do my absolute value here, and 3 minus 4 happens to be a negative 1. Now I just did 3 minus 4. I haven't actually gotten rid of the absolute values. I'm going to carry down everything that I did not underline. And we're going to continue. Once again, this is still considered a grouping symbol because we still need to complete whatever operation is in here, whatever operation this is telling us to do. So I need to go ahead and simplify that. So the absolute value of negative 1 happens to be positive 1. Remember, absolute value is how far away from 0 is that number. Well, negative 1 is 1 place away from 0. Now this becomes multiplication when you take that negative 1 out of the absolute values, since that 2 is butting up to that absolute value sign. So I'm going to carry everything else down. I've got division, plus, and multiplication. So it looks like I've got division and multiplication. What do we do first? We go left to right. So 10 divided by 5 is 2, plus 2 times 1. Now I've got plus and times. Times comes first. 2 times 1 is 2. 2 plus 2 is 4, and that's your final answer. All right, let's go ahead and look at our final problem. This is problem number 4. 5 plus negative 2 to the third times 2, all divided by 6 times the square root of 9 minus 9 times 2. What I've given you here is another grouping symbol. Actually, I've given you several grouping symbols. The first grouping symbol is the fraction bar. And since this is a grouping symbol, what it means to us is that we need to simplify the numerator first, then simplify the denominator, and then we can go ahead and combine the two if it's possible. There's another grouping symbol here that's kind of hidden, and that's the grouping symbol of the square root. Anytime you've got an operation underneath a grouping symbol that you need to complete or simplify, it's considered a grouping symbol. So we'll need to reduce this square root before we do anything else in the denominator. But first I'm going to look at the numerator before I even look at the denominator. I'm just going to simplify my numerator one at a time. My operations, it looks like I've got a plus, an exponent, and a times. In this case, exponents come first, so I would do that negative 2 to the third first. Negative 2 to the third is negative 2 times negative 2 times negative 2, which is in fact negative 8. So what I've got is 5 plus negative 8 times 2. And I'm going to leave my denominator blank here, and I'm going to continue to simplify my numerator. My operations now are addition and multiplication. Multiplication, in fact, would come first. So what we've got is 5 plus a negative 16. And 5 plus a negative 16 happens to be negative 11. Now let's look at the denominator. Well, like I said before, we've got the grouping symbol of the square root here that we need to simplify first. So what we have in the denominator is 6 times 3, which is the square root of 9, minus 9 times 2. So I simplified my square root of 9 first. Now it looks like I've got multiplication, subtraction, and multiplication. When we've got multiple multiplications, we go left to right. So 6 times 3 would be first, which would be 18, minus 9 times 2. Once again, we've got subtraction and multiplication, so my multiplication needs to come first. Looks like I've got 18 minus 18, leaving my answer as negative 11 over 0. Now, I want you to be really careful. A lot of students at this point tend to write no solution. However, I didn't ask you to solve this. The word no solution is used when there is nothing you can plug in for x to get a solution. There isn't even an x in this problem. When this happens, we know that you can't divide by 0, so we know that something's wrong. This is not no solution. This is undefined. The solution to this problem, or the simplification of this problem, would be undefined. Don't use the word no solution. Don't use a 0 with a slash through it. Use the word undefined. We're not solving for x, so the words no solution don't apply in this particular problem.